Okay, dear students, in this session discussing about the alkanes, which is more useful for the ICSE 10th class students. Now, alkanes. So, what is meant by alkanes here? The general formula of alkanes. General formula of alkanes is CnH2n plus 2. In this case, we can write n is equal to 1, 2, 3, 4, so on. Then if we write n is equal to 1, we can get CH4 and n is equal to here C2H6, n is equal to 3, C3H8, n is equal to 4, C4H12, like this we can get. So here, how many number of carbons are present in this one? 1. That's why the IUPAC name of this compound is methane. A indicates what? A indicates carbon-carbon single bond. And how many carbons are present here? It is 2 carbons. That's why each A. And 3 carbons are present. That's why we can write propane. 4 carbons are present. Butane. Now, in all these compounds, what we are writing here? N. That means carbon-carbon single bond is present in all these compounds. Now, if you write the condensed formula of these molecules and the structural formula of these molecules. Here, the condensed formula of these molecules. Condensed formula means we can write here the CH4 for methane, C2H6 that means CH3. Observe which bond is present here? Carbon-carbon single bond is present. Propane means CH3, CH2 and CH3. Next one, butane, CH3, CH2, CH2 and CH3. Now in all these molecules, what we are writing? Carbon-carbon single bond. Carbon-carbon single bond here. Then if you write the structural formula of these molecules here, structural formula. That means carbon is surrounded by how many hydrogens? 4 hydrogens. This is here. That means carbon can give the 4 bonds with 4 hydrogen atoms, but all hydrogens are giving single bond only. Okay, single bond. That's why we can say here the tetravalency of this carbon is satisfied. The tetravalency of this carbon is satisfied by 4 hydrogen atoms. From these we can understand one point. Hydrogen always gives the single bond only. Hydrogen always gives the single bond. That's why. And one more point here. This is a covalent bond. This is a covalent bond here. Covalent bonds basically 2 types. One is here sigma bond and one is pi bond. Covalent bond is a 2 types, sigma bond and pi bond. Sigma bond is formed by axial overlapping of atomic orbitals. The atomic orbital of hydrogen and hybrid orbital of carbon overlaps with each other axially, producing the sigma bond. Then we can learn that point in the hybridization concept. That's why here in this one we can say the sigma bonds are present around this one. 4 sigma bonds are present. That means we can understand finally single bond is a sigma bond. Single bond is a sigma bond. So I told one more point. Pi bond. Pi bond is also covalent bond. Pi bond is formed by lateral overlapping of atomic orbitals. Lateral overlapping of atomic orbitals here. So lateral overlapping means what? Above the axis and below the axis, the overlapping of atomic orbitals is given. That's why here that is a pi bond formation. But in this case here, this is here the 4 sigma bonds. Now come to the second one, ethane molecule. In ethane molecule, how many bonds are present here? CH3 and C and CH3 here. Okay, this is here the structural formula of this compound. How many bonds are present here? Single bonds. 7 single bonds are present. That's why 7 sigma bonds are present in this molecule. The next one we can take here this molecule propane. So propane here CH3. CH3 means we can say here CH3. All hydrocarbons are given the single bond. So not only in these molecules, every alkane molecule, hydrogen always gives a single bond with carbon atom. Carbon also giving the single bond with the carbon atom. Okay, that's why here, this is here the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonds are present in this molecule. Then next one we can take here the structural formula of butane. So here structural formula of butane is given CH, and C here. So finally what we can say is every alkane molecule, carbon is a single bond, carbon hydrogen is a single bond. This is here the structural formula and molecular formula and the condensed formula for alkanes. But in every alkane, observe these two suppose here. In these two, how many carbons are different is there? One carbon. How many hydrogens difference is there? Two hydrogens. That's why here CH2 difference is given. In this case, CH2 difference. In this case, CH2 difference. That's why any two successive molecules are differed by one CH2 group. Any two successive molecules are differed by one CH2 group. One CH2 group difference is there. That means here the alkanes can give the which one here homologous series here. Alkanes can form the homologous series here. So what is meant by homologous series? The series in which any two successive molecules differed by one CH2 group. The series in which any two successive molecules are differed by one CH2 group known as a homologous series. One CH2 group means what is the molecular weight difference? Carbon is a 12, two hydrogens 2 into 1. That's why the molecular weight difference is the 14. Any two successive molecules. That's why alkanes can form the homologous series here. This is the general formula and here examples with the IUPAC names and the structural formula contains the formula. But if we take another point here, in this one what we know carbon-carbon single bond is present. Carbon-carbon single bond means here the bond length of this one is 1.54 angstroms. Bond length of this one is 1.54 angstroms. Bond length of carbon hydrogen bond is 1.11 angstroms here. So this is the bond length of carbon-carbon and bond length of the carbon hydrogen. The next one, these alkanes are called as paraffins. Alkanes are called as paraffins. Para means what here it is little and fins means affinity. Para means here little, fins means affinity. The less reactivity is given for the alkanes. That's why they are called as paraffins. The next one we can take here, alkanes exist in where they exist in this one here. Our principal source of alkanes are natural gases. Principal sources of alkanes are natural gases here. So that's why here the natural gases and petroleum products. In petroleum products, the alkenes are present here. So this is here the principal source of alkanes. The next one, alkanes exhibit the isomerism. So what is meant by isomerism here? Alkanes can exhibit the isomerism. Iso means same. Mar means parts. Okay, mar means parts here. So what is the definition of this one? Molecules with the same molecular formula with the different properties. Molecules with the same molecular formula with the different properties are called as the isomers. The phenomenon is called as the isomerism. Alkanes can exhibit basically two types of isomerism. One is chain isomerism, one is a positional isomerism. So that's why we are discussing about the chain isomerism of alkanes. That's why here chain isomerism of alkanes we are discussing. Chain isomerism means what? Chain isomerism means here isomers having same molecular formula, but number of carbons in the principal chain is different. Isomers having the same molecular formula, but number of carbon atoms are different. Carbon atoms are different in principal chain. In the principal chain, that is known as a chain isomerism. If we take the example for the chain isomerism, the example of chain isomerism is here. And is suppose I am taking butane. Butane molecular formula is C4H10. Butane can form two chain isomers. How? First one here, CH3, CH2, 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 and CH3. The name of this compound is known as N-butane. N-butane means what? N-butane means here all carbons are present in the chain form. All carbon atoms are present in chain form here. In this one, we will take the second one, that is CH3, CH3, CH3. This is here the second molecule. How many carbon atoms are present in the principal chain? 3. You can select any number of carbon atoms. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's why after selection of this one, this group is acting as a substituent. Then the name of this molecule is 2-methyl propane. 2-methyl propane. Pro is a root word. Pro is a root word. Ane is a single bond, and 2-methyl is the position of this carbon at this. That's why here, at the second carbon, 2-methyl means methyl is. Then finally, what we can say, number of carbon atoms in this one is the 4 in principal chain. Number of carbon atoms is the 3 in the principal chain here. So this is here the which one? The chain isomers given by the butane. But if we take the next pentane, pentane molecular formula. Pentane molecular formula is C5H12. Pentane can form the 3 chain isomers here. First one is here CH3, CH2, 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 and here this is the pentane molecule. But all carbons are present in which form here? Chain form. Okay, that's why here this is known as a chain isomer, that is N-pentane. The name of this molecule is N-pentane. And if we take the second one, CH3, CH2, CH2, and here changing the position of this group here. Very simple. I am writing this carbon at this position. Writing this carbon at this position. Then what happens here? CH3, CH2, CH3, and CH3. Then select the longest carbon chain. 1, 2, 3, 4. Okay, that's why here. At second carbon, one substrate is present. At second carbon, one substrate is present. That's why we can say here 2-methyl butane. 2-methyl butane is IUPAC name of this compound here. But the common name of this compound is known as a isopentane. Common name of this compound is isopentane. Why it is called as a isopentane? Yeah. So this position, the CH3 is nothing but iso. Here CH3 is nothing but iso. But totally how many carbons are present in the molecule? 5. That's why we can say it is called as a isopentane. The next one we are taking the third one, neopentane. Neopentane means what? Neopentane means here one carbon is surrounded by 4 carbons. One carbon is surrounded by 4 carbon. That carbon is called as a neopentane. That's why CH3, 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 and CH3. We can select the longest carbon chain from any direction. Here it is 1, 2, 3, 1, 2, 3, 1, 2, 3. Any direction you can select along this carbon chain will get the same. That's why here it is one of the substituent, it is one of the substituent. And that's why we can say here 2, 2, dimethyl 2, 2, dimethyl pentane is the name of this compound. 2, 2, dimethyl pentane is the name of this one here. But in this one here, the common name of this one what we call neopentane. Neopentane is the common name of this compound here. So this is here the isomerism given by butane and pentane. Like this, hexane, heptane, like that we can give here the isomers given by the alkanes. So this is here the chain isomerism given by the alkanes. But after that, we can explain here types of carbon atoms. Types of carbon atoms here. So how many types of carbon atoms are present generally? 3 types of carbon atoms are present here. Actually, you can give the fourth one, neocarbon. That's why here types of carbon atoms here. First one is primary carbon, secondary carbon, and tertiary carbon here. What is meant by primary carbon? The carbon which is linked with one carbon atom only. The carbon which is linked with one carbon is called as a primary carbon. Suppose here if we take this one CH3, CH2 and CH3. So this carbon is linked with one carbon only. This carbon is linked with 2 carbons here, but this carbon is linked with one. That's why here the carbon which is linked with one carbon is called as a primary carbon. The carbon which is linked with 2 carbon atoms, that is called as a secondary carbon. The carbon which is linked with 3 carbon atoms, that is called as a tertiary carbon. So here, if we take one example for all these here, the carbon which is linked with 4 carbon atoms, that is called the neocarbon or quaternary carbon. Then if we take this one here, CH3, CH3, CH2, CH3 and CH3, next one CH3. So this is the example. In this example, they ask the question, how many number of primary carbons are present, how many number of secondary carbon atoms, tertiary carbon atom, neocarbon atoms here. That's why we can write number of primary carbon atoms here. Number of primary carbon means this carbon is linked with how many carbon? This is linked with one only. That's why it is the primary. This is linked with one only. It is the primary. This is linked with how many carbon atoms? 3 carbon atoms. That's why it is here the tertiary. This carbon linked with the 2 carbon atom. That's why it is the secondary. This carbon linked with 4 carbon. That's why it is the quaternary. And these 3 are known as the primary, and primary. That's why how many number of primary carbons are present? 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. That's why number of primary carbon atoms are there. The next one, number of secondary carbon atoms. How many secondary carbons are present here? 1. Number of tertiary carbon atoms. How many tertiary carbon atoms are present? 1. Number of neocarbons, that is quaternary carbons. How many are there? It is also 1. Then based on this one, they will ask one question. That is number of primary hydrogen atoms. Number of primary hydrogen. The hydrogens present on primary carbon are known as the number of primary hydrogen. How many hydrogens are there? 3. Here 3 and 3, 3, 3. So that's why each primary carbon is linked with 3 hydrogens in this one. That's why finally is 15. 15 primary hydrogens are present in this molecule. The next one, number of secondary hydrogen atoms. Number of secondary hydrogen atoms are how many? This is carbons are 1. That's why linked with 2. So it is 2. The next one, number of tertiary hydrogen atoms. Number of tertiary hydrogen atoms are how many? It is 1. That's why this is the 1. The next one, number of neohydrogen. Neohydrogen is not possible. Because neocarbon means what? The carbon which is linked with 4 carbons is called the neocarbon. So finally, this is a way to identify the number of primary, secondary, tertiary carbon atoms in this one. The next one, we are taking that is here. The occurrence of alkanes molecule. Especially we are discussing methane and ethane. Methane occurs where? The occurrence of these compounds here. Methane basically occurs, okay? Methane basically occurs at the bottom of the marshes due to fermentation of cellulose. Due to fermentation of cellulose, methane can occur bottom of the marshes here. That's why the methane is called a marsh gas. Methane is called a marsh gas due to formation of gas at the bottom of marshes due to fermentation of cellulose. Due to fermentation of cellulose is known as a, that is here the occurrence. The next one, the methane is also present in the cavities of coal. The 90% of cavities of coal are filled with methane gas. That's why here 90% of cavities of coal, 90% of cavities of coal filled with the methane gas only. That's why here the methane is called as a fire dam. Fire dam. What is the meaning of fire dam? Easily catch the fire. Easily catch the fire. That's why it is called as a fire dam here. The next one, ethane. Occurrence of the ethane here. Ethane can occur along with the methane. Ethane can occur along with methane. 10 to 20% of ethane is present along with methane. 10 to 20% of ethane is present along with methane. This is here the means where the methane is present, there the ethane compulsory present, but very less amount of ethane is present along with methane. So this is here the occurrence of the methane and ethane molecule. The next one, structure of the methane and ethane, how it is explained. The structure of methane and ethane. So that's why here structure of methane we are discussing. Structure of methane. In this one, what is the atomic number of carbon here? 6. We know configuration of this electronic configuration 1s2, 2s2, 2p2. 2p2 means how we can write the electrons in 2p2. 2 electrons are present in 3 p orbitals. We know the p orbital is having 3 suborbitals, px, py, pz. That's why 2 electrons are present in this one here. 2 electrons are present in this one. But after the excitation of electron, so here excited state I am taking. So excited state means this configuration is called as 2s2 2p. Okay, that's why here this electron is jumping into this one. After the excitation means what we can say, jumping of electron from one orbital to another. So that's why here the same energy level is the same, but changing its position. That's why we can write here 2s1 and 2p3. It is 2s1, it is 2p3. In this condition, all these atomic orbitals mix with each other. In this condition, all these atomic orbitals mix with each other and producing the 4 hybrid orbitals. Those are known as sp3 hybrid orbitals. Those are known as sp3 hybrid orbitals. That's why 4 sp3 hybrid orbitals are given for each carbon in this one. Then these 4 hybrid orbitals having 1 electron here. These 4 hybrid orbitals are having 1 electron. Because in which manner electrons are present? In same manner the electrons are present in hybrid orbital. Each hybrid orbital overlaps with the 1s1. Okay, each hybrid orbital overlaps with 1s1 of 4 hybrid orbitals. So how they arrange these hybrid orbitals here in tetrahedral manner. In tetrahedral manner, they arrange themselves. That's why the structure of methane is known as a tetrahedral. Then we can write the structure of this one here: hydrogen, hydrogen, and hydrogen. Then this is here the hydrogen. So I am giving the dark line for this one here, which is given dark line. That is here near to the viewer or above the plane. Suppose this is the plane, then above the plane one hydrogen is present, below the one plane hydrogen is present, on the plane two hydrogens are present. That's why which is present above the plane, that is denoted by dark, which is present below the plane, that is denoted by dotted, and the meaning of dark is near to the viewer. Okay, suppose above the plane, below the plane, if we make this molecule, this is becoming near to the viewer, this is far to the viewer. Then on the plane, two hydrogens. That's why here, this is here the structure of molecule in this one here. So finally, what we can say, the tetrahedral structure is given. The bond angle of this one is 109 degrees 6 minutes. Is the bond angle of this one. All bond angles are same in this one. This one, this one, this one. That's why 4 bond angles are there. Each bond angle is equal in this one. So this is about which one here. The structural information of this one. Not only in methane, in all alkenes, all carbon atoms involves in sp3 hybridization. Involves in sp3 hybridization compulsory. Bond angle is compulsory 109 degrees 6 minutes. Geometry is a tetrahedral. So this is here the explanation part of here structural information, isomerism, and general information of these alkenes. The remaining part will discuss by means physical properties and chemical properties by next session. Okay, so I think we understood here. And if anything are needed, we can give in a suggestions in the here comment box. Please comment on this video, and the remaining part will discuss by next class. Thank you.